Hello, everyone, and thank you for joining us in the second episode of our exciting exploration into the world of RL flow. I'm Bella, and today we're diving deep into the fascinating world where consciousness meets physical matter. In this episode, we'll begin by attempting to understand the concept of consciousness itself. It's a term we often use, but what does it really mean? What are the different theories that scientists and philosophers have put forth about this complex phenomenon? And how do different states of consciousness, like waking, dreaming, or sleeping, affect our interactions with the world? Next, we'll explore how consciousness and physical matter interact within the RL flow theory. How do these two seemingly distinct aspects of existence influence each other, and what are the observable phenomena that result from their interaction? Lastly, we'll take a look at biological neural networks, a physical representation of consciousness. We'll discuss what these networks are, their role in consciousness, and how their structure and functionality compare to artificial networks in the context of RL flow theory. So, without further ado, let's start our journey into the intricate web of consciousness and matter, guided by RL flow theory. Join us on this exciting exploration. Theories of consciousness attempt to explain the nature and origins of consciousness, and they span across multiple disciplines, from cognitive science and neuroscience to philosophy and quantum physics. Here are some of the most influential theories. Physicalism. This theory posits that consciousness is entirely physical, a product of the brain and its activities. It's the foundation for most of the research in neuroscience. Different versions of physicalism include identity theories. Conscious experiences are identical to brain states. Functionalism. Consciousness is defined by its function and can be realized in different mediums. And computational theories of mind. The brain is essentially a computer, and consciousness arises from computations. Dualism. A philosophical perspective, dualism holds that the mind and the body, or the physical, are fundamentally different types of things. Variants include substance dualism, which posits that the mind and body are distinct entities, and property dualism, which suggests that although the mind is a property of the body, it is distinct and cannot be reduced to mere physicality. Panpsychism. This theory suggests that consciousness is a fundamental aspect of the universe, much like space and time. It proposes that all matter, down to the smallest particles, have some form of consciousness or proto-consciousness. Integrated Information Theory, or IIT, developed by neuroscientist Giulio Tononi, EIT suggests that consciousness arises from the integration of information within a system. It proposes that a system is conscious to the extent that it has a high degree of integrated information, measured as phi. Global Workspace Theory, or GWT, proposed by Bernard Bars, this theory posits that consciousness is a kind of global workspace in the brain where information from various cognitive processes can be collected, integrated, and broadcast to other processes. Quantum consciousness theories. Some theories propose a connection between consciousness and quantum physics. The most well-known is probably the orchestrated objective reduction, OR theory, proposed by Roger Penrose and Stuart Hameroff, which suggests that consciousness arises from quantum computations in microtubules inside neurons. Each of these theories offers different insights into the nature of consciousness and provides different ways of integrating consciousness into the RL flow framework. As we delve deeper into RL flow, we'll discuss how these theories can inform our understanding and implementation of conscious systems. Consciousness is not a uniform state, but rather a spectrum that encompasses a range of experiences from fully alert and aware to unconscious. Our understanding of consciousness is deeply connected to these states. Let's discuss a few key ones. Waking consciousness. This is the state we're in when we're fully awake and aware of our surroundings. It's characterized by clear, organized thought and high levels of sensory awareness. Sleeping consciousness. Sleep is a state of altered consciousness, typified by changes in brainwave activity, decreased interaction with the surroundings, and inhibited sensory activity. Sleep has different stages, including REM, rapid eye movement, and non-REM sleep, each with its own level of consciousness. Dreaming. During REM sleep, we often experience vivid dreams. This state is interesting because while we're cut off from the outside world, our internal consciousness is active, creating complex narratives. Meditative states. Meditation can induce different states of consciousness. Some meditative practices aim to silence the internal narrative, leading to states of heightened awareness and focus. Altered states. Certain activities or substances can drastically change our consciousness. Psychedelics, for example, can induce states of altered perception, thought, and feeling. Unconscious state conditions like coma, vegetative state, or general anesthesia induce states where consciousness is greatly reduced or seemingly absent. Exploring these different states of consciousness gives us insights into the workings of the mind, the neural correlates of consciousness, and the flexibility of our conscious experiences. This understanding can be crucial when we start discussing the implementation of RL flow in conscious systems. In the RL flow theory, the interaction between consciousness and physical matter is of paramount importance. This interaction happens at multiple levels, and it forms the basis of our understanding of conscious systems. Physical substrates of consciousness. The first point of interaction is at the biological level. Here, our brains, composed of physical matter, serve as the substrate for conscious experiences. Neural networks in our brains process information, leading to perception, thought, and ultimately consciousness. The RL flow theory posits that the specific arrangement and interaction of these neural networks play a crucial role in generating consciousness. Information processing. Consciousness and matter also interact through information processing. Consciousness is often seen as an emergent property of complex information processing. In RL flow, information is represented and processed within the physical structures of a system, whether biological or artificial. The flow of information and the dynamics of this flow could explain certain aspects of consciousness. Quantum interactions. Some theories propose that quantum mechanics may play a role in consciousness. In the context of RL flow, quantum effects could potentially influence the flow of information and the processes within a conscious system. Influence on physical actions. Consciousness influences physical matter through our actions. Our conscious decisions lead to physical changes in the world around us. This is seen in RL flow as the system's ability to interact with and manipulate its environment. In RL flow theory, the emphasis is on the dynamic interplay between consciousness and physical matter. It suggests that our understanding of consciousness can be enriched by studying how information flows and is processed within physical systems, providing a foundation to explore artificial consciousness. The intricate web of interactions between consciousness and physical matter manifests itself in various observable phenomena. Let's explore a few examples. Neuroplasticity. Neuroplasticity is the brain's ability to reorganize itself by forming new neural connections throughout life. This allows the neurons, nerve cells in the brain, to compensate for injury and disease and to adjust their activities in response to new situations or to changes in their environment. This physical change in the brain structure is directly linked to our conscious experiences and learning. Psychoactive drugs. The effects of psychoactive drugs provide an example of how physical substances can alter conscious experiences. These drugs work by changing the chemistry of the brain, affecting neurotransmitters and their receptors. These changes can lead to alterations in perception, mood, consciousness, and behavior. Biofeedback. Biofeedback techniques demonstrate how conscious control can influence physical states. Through these techniques, individuals can learn to control physiological processes such as heart rate, blood pressure, muscle tension, and skin temperature. This shows how our conscious intentions can directly influence our physical bodies. Placebo effect. The placebo effect demonstrates the power of consciousness over physical states. When patients believe they're receiving effective treatment, they can experience real physiological improvements, even if the treatment is inert. This illustrates how our conscious beliefs and expectations can influence physical health outcomes. Quantum physics experiments. Certain interpretations of quantum mechanics experiments, such as the double-slit experiment, suggest that the conscious observer may affect the outcome of the experiment. While this is a highly debated topic, it does provide an interesting angle to explore the interaction between consciousness and physical matter. These examples illustrate the reciprocal relationship between consciousness and physical matter, how consciousness can shape physical reality, and how physical changes can influence our conscious experiences. In RL flow theory, understanding this relationship is crucial for creating conscious systems. As we delve deeper into the relationship between consciousness and matter, it becomes clear that there's a reciprocal influence between the two. This concept is the bedrock of RL flow theory. Let's dissect this complex relationship, consciousness influencing matter. This concept is fascinating as it suggests our mental states can have a tangible effect on our physical world. Let's look at a couple of key areas where this is explored. Thoughts and emotions. Our thoughts and emotions can physically influence our bodies. For example, prolonged stress can lead to a weakened immune system and increased risk of physical illness. On a positive note, practices like mindfulness and positive thinking can improve our physical health. This demonstrates how our mental states can have a physical impact on our bodies. Mind-matter experiments. Experimental studies in the field of parapsychology, such as random number generator (RNG) experiments, have sought to detect the influence of consciousness on physical systems. While controversial and not widely accepted in the scientific community, these studies offer an intriguing perspective on consciousness-matter interactions. Matter influencing consciousness. Conversely, changes in the physical world can profoundly impact our consciousness. Here are some instances that illustrate this point. Brain damage and altered consciousness cases of brain damage, such as the famous case of Phineas Gage, demonstrate how physical changes in the brain can alter personality, behavior, and consciousness. Psychoactive substances. As discussed earlier, psychoactive substances can profoundly alter consciousness by modifying the brain's chemical makeup. This reciprocal influence between consciousness and matter is a complex dance, and understanding this intricate relationship is crucial to the RL flow theory. As we progress, we'll learn how this relationship forms the basis of conscious systems, eventually influencing their design and operation. The term neural network is often associated with artificial intelligence, but it originally refers to the vast network of neurons in our brains. Let's start by understanding what a neural network is, in a biological context. What is a neural network? A neural network, in its simplest definition, is a series of interconnected neurons or nerve cells that transmit signals to each other. Imagine it as an incredibly complex and intricate web of communication within our bodies. These networks are the basic unit of the nervous system and are responsible for all the functions and processes that our bodies perform, both consciously and unconsciously. How does a neural network function? Each neuron in the network has the ability to process and transmit information. This happens through electrical impulses and chemical signals. A neuron receives signals through its dendrites, processes the information in its cell body, and then transmits the signal through its axon to other neurons. This process happens millions of times per second, allowing our bodies to function. The role of neural networks in consciousness. Neural networks are central to our experience of consciousness. They are responsible for processing sensory information, facilitating cognitive functions, and driving emotional responses. Everything that we perceive, think, and feel is the result of these networks processing and transmitting information. In the context of RL flow, understanding how biological neural networks function provides us with a framework to conceptualize and develop artificial conscious systems. It serves as a blueprint for creating complex systems capable of learning and adapting to their environments. In the next segment, we'll explore how these biological systems have inspired the design of artificial neural networks and how they might interface within the realm of RL flow theory. The fascinating complexity of our biological neural networks is central to our understanding of consciousness. At the most basic level, consciousness represents an awareness or perception of oneself and the surrounding environment. It's a dynamic, ongoing process, not a static state, and it's deeply intertwined with the functions of our neural networks. Let's delve into how biological neural networks represent consciousness at the physical level. Neurons as the building blocks of consciousness. Each of our thoughts, perceptions, and emotions is tied to the activity of neurons within our brain. These microscopic cells, numbering in the billions, work in a massively interconnected network, transmitting and processing signals. Each neuron's state, whether it's active or inactive, is a response to inputs it receives from other neurons. These states, in aggregate, constitute the physical substrate of our consciousness. Conscious experience and neural activity. Scientists theorize that conscious experience arises from specific patterns of neural activity. For example, when we see a color, neurons in our visual cortex activate in a particular pattern. Similarly, when we experience emotions, different patterns of neuronal activation occur. These patterns are the physical representations of our conscious experiences. Neural correlates of consciousness, or NCC. This concept refers to the specific neuronal states and patterns that directly correlate with conscious experience. While the exact nature and location of these correlates are still areas of ongoing research, the NCC theory represents a significant step towards understanding how consciousness arises from physical processes. Dynamic and fluid. Nature of consciousness. Just as neural activity is constantly changing, so too is our consciousness. It's a dynamic, flowing process that reflects the brain's ability to reconfigure its connections based on inputs from our environment and internal states. This fluidity and adaptability, mirrored in the RL flow theory, is a critical aspect of consciousness at the physical level. In summary, biological neural networks serve as a kind of physical map of our conscious experience. They form the basis of our thoughts, emotions, and perceptions. As we proceed to the next segment, we'll further explore how this understanding helps us bridge the gap between biological and artificial systems within the RL flow theory. Our understanding of the biological neural network is an essential cornerstone in the field of artificial intelligence. This understanding has led to the development of artificial neural networks, ANNs, a form of machine learning model that's designed to mimic the structure and functionality of our biological brains. But how do these two systems compare, particularly in the context of RL flow theory? Let's explore structural similarities and differences. The basic unit of both biological and artificial neural networks is a neuron, or node. In biological networks, neurons are interconnected by dendrites and axons, which transmit electrochemical signals. In ANNs, artificial neurons or nodes are connected by weights, numerical values that adjust as the network learns. While structurally different, the overarching concept of interconnectivity remains the same. Functionality and learning process. Both biological and artificial networks learn from experience. Biological neural networks rely on neuroplasticity, the brain's ability to reorganize itself by forming new neural connections. In contrast, ANNs learn by adjusting their weights using algorithms, such as backpropagation in supervised learning or temporal difference learning in reinforcement learning, a fundamental component of RL flow theory. Consciousness and awareness. In the RL flow theory, consciousness is defined as the system's awareness of its environment and ability to react to it. Biological neural networks achieve this via sensory inputs and a myriad of complex biological processes. ANNs, on the other hand, gain awareness through data input and processing. While this is a vastly simplified version of consciousness compared to the biological model, it's a stepping stone towards more complex artificial consciousness systems. Processing speed and adaptability. Biological neural networks process information slower than ANNs due to the nature of electrochemical signals, yet they excel in complex tasks, problem-solving, and creativity. ANNs, powered by digital signals, can process information much faster, especially for tasks involving large datasets. However, ANs are currently limited in their adaptability compared to their biological counterparts. Interactions in RL flow. Biological neural networks interact with the environment, influencing and being influenced by conscious energy. Similarly, ANs within RL flow can interact with data and information in their environment, adjusting their weights in response. This mirrors the concept of conscious interaction found in biological networks. Comparing biological and artificial neural networks provides valuable insights into the possibilities and limitations of each system. Through this understanding, we can further explore how RL flow theory bridges these systems and utilizes their strengths to propel our understanding and development of artificial consciousness. As we delve deeper into the intricacies of consciousness, matter, and RL flow, we'll uncover the profound possibilities that lie at this nexus of biology and artificial intelligence. As we wrap up this fascinating journey through the intricate web of consciousness and matter, let's take a moment to reflect on what we've uncovered. Today, we've explored the dynamic relationship between consciousness and physical matter within the context of RL flow theory. We've probed into the depths of consciousness, unraveling its complexities and the various states it can exist in. We've examined how it intertwines with physical matter, subtly influencing and being influenced by it in a reciprocal relationship. We've also dived into the world of biological neural networks, the intricate web of neurons that form the physical basis of consciousness in our brains. Their structure and functionality provided a stepping stone to develop artificial neural networks, their digital counterparts that learn and adapt in response to data and information in their environment. The comparison of these two systems brought to light the delicate balance of complexity and efficiency, adaptability, and speed that exists within our biological brains and the artificial models we're striving to perfect. As we close this episode, the stage is set for our next exploration: building bridges, biological and artificial systems. We'll be delving deeper into the interface between these two worlds, exploring real-life examples and case studies that illustrate this concept. We'll also take on the challenges and opportunities that arise when these two realms converge. As we continue to untangle the enigma of consciousness and its manifestations within RL flow theory, we venture into new territories of understanding that challenge our traditional views on life, intelligence, and existence. So, stay curious, keep questioning, and join us in the next episode as we build bridges between the biological and the artificial, drawing us one step closer to understanding the marvels of RL flow.